the stream set up?
Yep.
Okay, nice. Just making sure.
Oh yeah.
Yeah, thanks for
He
reminding
reminded
me.
himself before I was gonna remind him.
Yeah, I just really don't want to forget again. For like the second time or third time. Alright, so everybody who's here for the workshop, remember to download this Unity package before we start. You can get it at this link. I'll actually put it in chat. Or you can find it in the EGaDS announcement for this workshop. And just try following these instructions to import it into a new Unity project, and we'll get started in about 5-6 minutes. How you guys been? Just in general, just in life.
Kind of tired.
We are kind of like getting to the end of the school year.
Yeah, it's kind of crazy. We've got like
Yeah.
a month left of classes or something.
It's also kind of crazy that next semester we're not gonna be in COVID hell anymore.
Yeah,
Don't jinx
really
it.
weird.
Yeah.
No, don't jinx it, please.
Yeah, Alex.
Everything's gonna be
all
great.
your fault.
Nothing's
If we're
bad's
not
gonna
in person
happen.
next
COVID's
semester.
never gonna come back.
Stop. Speaking.
Okay. Does anybody need the download link for this package? Just checking before we start. We're gonna get started in like 6:05, so there's still time to just get ready. Make sure you have a Unity project open because those take very long to make. What do you guys really want to learn how to cook? Like what dish? Is there anything that automatically comes to mind?
Like a recipe that I would want to learn like right now.
Yeah. Ratatouille.
Ratatouille, okay.
Ratatouille, that's a good one.
It just looks so good.
I've actually made it before. It's really good.
Yeah,
Really?
Word?
So cool.
Wait, how long did it take?
I was like, well, it's like a casserole kind of. So I think it took like an hour or so. Most of the time you put in. That's not including like thin slicing 12 vegetables though.
Okay.
Yeah. That sounds kinda
insane layered mac and cheese. Oh, that sounds so
heck
good.
Yeah.
Layered
mac and cheese by itself is already so good, and then more mac and cheese. Dang.
Yeah. Mac and cheese, but more. Some bacon, some. Oh, hot dog slices.
Yo, chives.
Heck yeah. Chives.
The breadcrumbs on
Breadcrumbs.
top.
Yeah, you
in the oven.
Gotta get panko on that.
Yeah.
Also, the fried garlic on top.
Oh, that sounds good.
Garlic bits. Yeah. So I bring this up because in 2 weeks we have our last workshop, and I'm not really interested in doing it in Unity. I want to do a cooking workshop for all the.
Wait, that's so good.
Yeah.
Any wait, do you have like the Overwatch cookbook or any of that stuff like that you could make something from?
Probably.
That'd be kind of fun.
We could get.
We should do like gamer. Wait, Alex, you should just get like no. You should just get like a Mountain Dew and some Doritos and be like, that's it. That's our gamer food.
Show us how to make Doritos at home.
Wait, what?
Mountain Dew mac and cheese.
Oh, Jesus Christ.
With Dorito breadcrumbs.
Hello, Evan.
Wait,
make sure you
good though.
Evan, make sure you've downloaded the workshops package, and if you need the link or like the Discord location, let me know. We're gonna get started in, let's say, 1 minute. I want to keep on talking about culinary workshop. I feel like it shouldn't just be me cooking. Like I might bring in some other officers, so it's not just me, and you can like watch multiple people cook. I think that's fun.
Just like everybody can just like cook together, and like anybody who's like cooking at the moment can just like turn their camera on and just like show what they're making.
Oh,
that does sound fun.
EGaDS Cooking Club.
Completely pivot the point of the word.
We would need to rework what our acronym stands for.
I don't know any culinary words to start with.
Edible.
Eating good,
delicious
stuff.
Yeah.
Wait, I'm so good.
Wait, you actually figured out how to make the A actually part of it too. Good job.
That's it.
Thank you.
But what's the cooking part? You're just eating.
No. Don't.
It's okay. I think the eating part is more important than cooking.
It's eating good and doing stuff.
Eating good, digesting seriously. I don't know. Okay, let's get started. All right. Last reminder: download the package at this link, or in the Discord announcement. Open a new project, drag it in, and you'll get something like this. I'll show you guys how to do that when I actually get to the Unity section. All right, so our topic this week is state machines. And you may have heard this term before and been like, yeah, I know what that is. But you may not have known all the different ways that you can make them and all the different uses. So let's get a little bit more into it. What is a state machine? Its more formal definition is a logic model where there are a finite number of states, each having its own behavior. And there are many examples of what a state machine can be. One example is Unity's Animator system. And that's because, only one animation can be playing at any given time. You can't be jumping and falling, and they both have their own individual, look. They animate differently. One example of this in game is Shovel Knight. It shows a really good example of this with one of the characters. You can see how King Knight, he has an idle state where he's just standing, completely normal, but you can also see he has a dash state right there and a spinning top state. And these all have very different behaviors. In his top state, he can't attack, he can only move around, and in his dash, he can't move at all. He's just like a pre-ordered thing. And something you might realize is that this kind of complex behavior and these different context-dependent actions are kind of difficult to program into Unity's basic, just start update functions, right? And that's where state machines come in. So if you have heard of state machines before, and if you've ever tried to make one, it's likely that you've tried to implement them with something called enums. Enums are practically just integers that you can give a name to each values, right? Because you can still check the value of an enum, but now you just check it with a name instead of a value. So falling would still be 0, throwing is 1, staying is 2, blah, blah, blah. But now you can refer to them by name. It helps with organization, and just helping you visualize what each of these enums mean. And something you would do is you define a couple different states, you have a reference to a state, and you update that state as you change the if you have some something that changes the state, you would just update your local variable. Am I going too fast? I feel like maybe I should slow down. I just want to make sure that anybody who's like completely new to this, isn't like getting thrown completely for a loop. Okay, well, if I am going too fast, let me know. I can always slow down. Alright, so other types of state machines can be found in the Unity asset store. You know, like, I haven't actually looked at these assets, so I don't know how good they are, but there are a lot of different ones that you can find. And for me, personally, I feel like buying one of these wouldn't be that good of an investment, just because, well, they're kind of expensive. And also, Unity kind of already provides a state machine through its Animator. And that's what we're actually going to be using today. And you might say, I mean, Unity Animator, that's for animation. Don't use it for logic. Don't do that. And to you, I say, I'm going to do it anyway. So you might have seen before with this Unity Animator, it has those states, it has those transitions. But how do we actually make them relate to actual logic and code? Well, for each of those states, you can attach something called a state machine behavior, and that's a script. And you can attach a script, you can attach one of those to each of these states. And I think you can attach multiple, but we're not going to be doing that today. So you can attach scripts to these states, right? And unlike most Unity scripts, they're not going to be a mono behavior. They're going to have the class of state machine behavior. And that just means it's inheriting a different class, and you don't have access to some of the functions that you normally would have in a normal mono behavior. So mono behavior is something that gives you like the transform, gives you like game object functions like, you know, dot translate or something, you know, dot destroy or something, and mono behavior also like implements collision stuff. And inside of these scripts that inherit from state machine behavior, you don't have any of that because it just inherits from something different. And you're going to have different functions, you're going to have a couple of different tools that I'll be showing you how to use today. Alright, so why use a state machine in the first place? Well, it's because when you're splitting up your script into a bunch of tiny ones and putting it into these individual states, it's very easy to use because your scripts are going to be really small. You're going to know exactly what they want to do because, you know, like most of the logic is splitting it up into stages. Once you have those stages, you know exactly what they want to do, how they behave. And that's also going to help you implement more complex behaviors because unlike in a normal update just loop, now you can kind of spread it out in like a lot of different states and a lot of different scripts. The last thing is that your code will be more readable, and that's partially just because there will be more scripts, but also since you're putting it into states, which is very visual, and kind of like you can kind of like lay out your states in a intuitive way. It lets people that are working with you kind of understand what your code's doing, what it's trying to do, and if something goes wrong, it helps them find a problem. And this is a very important point because if you're working in games, you're probably going to be working with other people, and if they can't read what you're doing, it's not very it's not very good for your team. Yeah, making your code readable is just as important as making it work. What are some limitations of using state machines? Well, as you can see, they can get pretty complicated. If you have a lot of states and you have a lot of different behaviors that you want to implement, it kind of balloons really fast, and you kind of get these big maps of states and stuff. But you can still see that even with all these behaviors, if you're using a state machine, you can lay it out pretty neatly. And like, if you were to think of implementing all those states in a enum state machine, well, you would just have a giant switch statement checking all of those different possible states, and that would just be massive, which is another reason to use Unity Animator instead of enums. Okay, so I put redundancy, and that means since you'll be having all these different states and you'll have scripts for each one, what happens if you want to access a variable that is shared between two of the states? You know, like they'll have the same value. I mean, like the automatic reaction is, oh, now you have to have two instances of the same variable that'll just have the same value. But we actually have a solution for that. That's like kind of, it's not the best solution, but it's good enough. And I also don't know if there's a better way of doing that. So I'd have to look into that more. But as far as I know, I'll show you guys the best way to deal with that. It's also decentralized, so like I kept on saying, you're splitting up your script and putting it on all these states. But sometimes that's actually kind of bad when you're debugging, because, okay, well, if you know the state where something's going wrong, it's very easy to debug. You know exactly where to look, you know exactly like what small section of code that you need to correct is. But if you don't know where that problem is, and you just have a bunch of states like this, well, now you have a problem, because now there's a lot of places to look, there's a lot of code to go through, and it quickly kind of becomes a little overwhelming. And that's why it's usually good coding practice, and something that I'll try to show you guys here, to kind of keep all your states isolated inside itself. So it's very easy to tell where the problem is and find it later if anything goes wrong. All right. So you might have seen it from the announcement, but today we'll be actually recreating the cap throw from Super Mario Odyssey, complete with like the bounce if you touch it, the throw, and the kind of, I mean, it's not shown here, but like if you throw it and hold the button, your hat will stay. And that's the three big features for this hat we're going to be implementing today. Okay, and also before I go to Unity, does anybody have questions about state machines or anything I talked about in the lecture? All right, if not, let's get started. So hopefully you guys have your scenes open already, and I'm just going to take the file that I had and drag it into this. Import all. I appreciate that, Jojo. That's a good meme. Man, am I the new AET curriculum? Maybe I shouldn't make that joke. Uh-oh.
That's a loaded joke. we can't be saying that here.
Oh man. Okay, so I opened the folder with the 1 in front of it and opened up the follow throw scene. And if you play this, you'll be able to see you have a capsule that you move around. I call him Capsario. He has a nose. You can kind of see it peeking over his head. And it's just a really basic third-person controller. Also, if you press, your cursor will be locked inside the screen. To get out of that, you press escape. And to go back in, you click. So escape releases your mouse. Okay, so let's talk about what's actually in the scene right now. We have Capsario. He has a hat position right on his head, and that's where we want our cap to follow. Is his nose. He has the camera that's attached to him. And we also have the model for the cap. And something you might notice with this cap is that I have its rigid body and mesh collider separated from its mesh render. And this is really just to make animation in the future easier. Doing this is almost always a good idea because if you want your animation to add some visual flair, you don't want it also altering your collider and stuff. Okay, so those are our basic pieces. Now let's start talking about how we're actually going to make a state machine. So first thing that we want to do is we're going to right click in our assets window down here, and we're going to create an animator controller. Let's call this hat. Sure. Next, we're going to click on our Mario hat and add a component, Animator. This will give us somewhere to put our animator controller. So drag the controller that you made into that component. I'm going to double click. And it's going to open the animator window. And what I did was just drag it next to my scene dock, so I can look at them side to side. Okay. So now I have my animator attached to my hat. And again, if there's anything that you guys have questions about, I will always stop. Yeah, I would much rather have you guys ask questions than like have you guys just like not be able to follow for the rest of the workshop. Okay, so we added our animator. Let's start adding a couple new states. So I'm going to right click within this window and I'm going to add a new state just by creating state empty. I'm also going to name this state following. Okay. So now that I have this state, I want to attach a behavior to it. Ignore those. Those are those are just for the final product. So I'm going to make a following script. Okay, there we go. So I'm gonna add a behavior called following. It's opening up Visual Studio. Cool. And you'll see that this following inherits from state machine behavior, where you would usually be inheriting from mono behavior for most game objects and components. Alright, so there's a lot of stuff here, but pretty much the only thing that we're going to be using are onState enter. So I'm going to uncomment that. And onState update. And these are very similar to monobehavior start and update. They're just called different things. And they also have a reference to the animator, which is specifically the animator that we added. So here, recall that we don't actually have a reference to transform. This is like the class. So you can't actually access your game object's transform directly. But since it passes in that animator, you can reference your transform by doing animator.transform, because animator inherits from monobehavior. Okay. So for our follow script, the first thing that we want to do is we want it to follow that head position on Capsario. So let's define a private transform head. Actually, you know what? We're going to be using private, but I'm going to show you why it can't be public. Alright, so it's a public variable, and you'll see... Man, this is really slow today. And you'll see that the transform gets serialized here, so on our animator here. And you'll also see, if I try to drag in this transform from our scene, it doesn't let me. And the reason for this is that our asset, our following script, is attached to our animator controller, and our animator controller only exists in our assets window. So technically, your script knows nothing about what's in the scene right now. It only exists in assets. It's almost like having a prefab. Because like prefabs, you can't keep references to the scene. It's just like not in the same dimension. Yeah, so you can't actually make public fields for something you want in scene. So instead, what we're going to do is we are going to attach we're going to attach a new script to our Mario hat that inherits from mono behavior. So let's call that hat. Ah, dang it. my name convention is bad. Okay, we're only gonna call it hat. Hat controller is the completed one. Dang it. Don't do that. I just want one that says hat, okay? I made a script called hat. Be very careful about that. You don't want name conflicts. Okay. So we've attached a new script, a new empty script called hat to Mario hat. We're going to double click on that. And we're going to say, we don't need these. We're going to say...
Alex, real quick, could you zoom in on your...
Yes.
On your text? Yeah, thank you.
Sorry about that. Okay, so we're going to have a public transform here, and this is going to be hat pause. Wait, what? Oh, okay. We're going to have a public transform reference here. And now that we've added it on that, it'll show up here, serialized, and we can drag in our hat pause on Capsario into this. And you might be wondering, well, that's a monobehavior script. That doesn't relate to our animator thing. That doesn't do anything. What are you teaching us? You're a fraud. But I'll say, that may be true, but we can actually access that monobehavior script by doing animator.getComponent, and we'll get the hat. And again, since this animator is attached to our hat, now we can access that hat script with getComponent. And then we access our hat pos from there and set it equal to our head in here. This is the solution to the redundancy problem I was talking about earlier. Because if you have, maybe not a transform, but like a float, and you want that number to be the same across multiple state scripts, well, you don't want to just like hand set the value for all of them. So the solution is to put that variable in this class, have that field, and then in the start of each of those scripts, you set that new float to that value. Again, like I said, this isn't a perfect solution. It still means that you need to go through the hassle of like getting the component and setting the values. But it is still better than having to do all of them by hand. Okay, so now that I have a reference to the head, I want the hat to follow. Now I want the hat to follow that position. So in our onState update, this is the exact same as the monobehavior update. We're gonna do animator.transform.position equals head.position. Okay. Right. So let's see if that works. Oh my god, Unity is so slow. Or maybe my computer is just really bad. Okay, oh. I did something wrong. I assume I just set the wrong transform. Yeah, I did. Okay, so now, nice, that our hat follows our head, which is exactly what we want. But you'll see that it still doesn't rotate with our head. Let's fix that now. So inside of this package, I actually included a library that I really enjoy using. It's called EGaDS. And to use this library, you have to include this line of code in your include statements. And what this library specializes in is moving or interpolating between two values on a lot of things like position, audio, color, opacity, a bunch of stuff. And you might say like, okay, well, just interpolating between two values, that's something you can do in Unity already with lerp, but it makes it very easy, so I like it. So something we're gonna do is we're going to do animator.transform.do rotate, and we're going to do head.euler angles. And we're just going to put a small value here, like 0.2. So what this library allows you to do is allows you to make tweens. And tweens are like actions. And when you use a function that's like do something, it makes a tween and applies it to whatever component that you called that function on. Right? So now this transform has a tween. That rotates it to be this eventual value. So if you look at this, this entire statement is make a tween that will rotate your angle to be the same as your head angle. And this value is how much time it takes to do that. Okay, so let's see how that looks now. And we got the rotate. The reason why I wanted to use that tween there is to kind of show off how just like a little bit of interpolation and a little bit of motion makes makes the graphics look really, really nice. Just like a little bit of polish, right? Okay. So now that we've got that, I want this cap to be thrown. So let's implement that. Let's say, okay, so let's go to hat.cs and let's add a public key code that's like throw key, and we'll set it equal to keycode dot mouse 0, and that's left click. So we're going to add this to hat, and next we're going to go back to following, and we are we are going to make a public, it doesn't need to be public. We can also make a private key code throw key. Again, you see that redundancy peeking its head out. We're gonna get the reference from hat. I just used to get components when I didn't need to. Very bad programming practice, but you know, I'm too lazy to just store a reference. It's fine. Just remember to do all the good coding practices that you normally do, because again, this is going to be like a normal script, just with a different inheritance. Okay, so now we have a reference to the throw key that we're using inside of following, and now let's actually check it. So if input dot get key down and throw key. So if we press the left mouse button, well, we want the animator to go to a different state. Specifically, we'll make a state called throwing. That's not how you spell throwing. Throwing. And this function will just automatically change the state. So if you've used Unity's Animator before, you know that you can use transitions, and you can make parameters within the animator to activate those transitions. But when we're doing something basic here, I think it's better to just swap the, to just play a different animation, because that'll just instantly change your state. This is almost like if you were using an enum state machine, changing that variable to something else. I think it's just a lot more clean. Okay. So, yeah. So we're going to add a new state in our animator, and we're going to call it throwing. And we're not going to add anything else in it for now. Alright. And I'm going to test this out. Okay. It still follows, but if I press left click, it doesn't follow anymore, which makes sense because it switched to that different state, and that state doesn't have any behavior, so it loses that following behavior. Cool. Also, I realized that I kind of went through a lot of code. Does anybody need me to go back to any section of code? Whether in hat following or even just like the animator. If everybody's good. Alright. Okay, I'm assuming everybody's good. So I'm just gonna keep going. Can I see the animator? Yes. So for this animator, I have two states, and one of them has a following script on it. Oh, this is public, but it can actually be private. Let me actually change that real quick. Private. Cool. Oh, I guess another important thing that you might need to see is Mario hat. And just remember that you want a hat script attached to that has a, doesn't stop following when I click. And you made the new state, right? Yeah, also make sure that you set the right key, maybe. Yeah, I am not completely sure where that might be happening, but don't worry. I include a working version after we implement following and throwing. This is just to kind of introduce you to the concept. So if it's not working now, you can catch back up on the next stage. Oh, nice. Cool. All right. So now that we have our state switching working, let's try adding another script for throwing. New script, throwing. Taking a while, like always. Okay. Right. So for throwing, pretty much all we want it to do is move forward, right? Because you know, we want it to move forward once and then stop. So let's import this library again, Tweening. And we are only going to be using state enter. Okay, so we want to know how far our cap throws and how fast it gets there. So let's add two variables, public float throw distance and a public float throw time. And we pretty much just want it to move forward, so animator.transform.do local move. Technically it doesn't have to be local, but I just do that for sanity. And we're going to do animator.transform .position plus animator.transform .forward. And then, you know, times throw distance and throw time. So let's recap what this is doing. This is going, at the very start of this state, it's going to run this code once. And it's going to move our transform. It's going to move it to this position. which is our current position plus some distance forward. And it'll do it within this amount of time. Okay, let's see how that works. And remember, we're going to have to update those variables. And since these are floats, they don't depend on anything in scene. We can actually change them here. I forget what I actually put these at. I'm gonna say 14.5. Okay, this is still working, and let's try throwing. There it goes. That was a little slow, so I think I'm going to decrease the throw time. But yeah, we can see that it moves forward in the direction that you're facing. Something that you might notice though is if I'm moving my mouse around a lot, so like say I do it like this, it didn't go in the direction that I was facing. And that's because we have that do tween on the hat, so it's technically not always facing the direction of your player. But if you want your platform to feel good, you want it to be responsive, right? So this is part of like how you might debug with state machines. So say that you know that you want it to go in the direction you're facing. Well, before you actually set the state to be your throwing state, something you could do is animator.transform.uWhereAngles is equal to head.uWhereAngles. And this will ensure that you're always entering your throwing state with the values that you want. And this is something you might not have to think about if you're doing like a normal script, but like you need to kind of understand what the state of your thing is in before and after it goes into each of these states. So kind of a different thinking space for coding, but it's something that can definitely be achieved, and I think it's kind of fun thinking about all the different scenarios. Okay, so I think that is pretty much all we want to do for the hat, for this stage. So pretty much at this point you should have a player that you can move around, and if you left click it throws the hat in front of them. Alright, just in case anybody fell behind, I have a pre-made scene with this stuff implemented. If you go into folder 2 and double click on stay return, you'll see that following and throwing have been implemented here. Oh yeah, also a really nice thing about using the animator to describe a state machine is that you can also add animations very easily. So let's look at the animator controller that we have here. This is the one that's used in the scene. So for following, I just have a normal animation that doesn't do anything, and for throwing, I put in a flying animation, which kind of squashes down the hat and makes it spin. And it's very easy to control these because we know exactly what animation we want for each of these states. Wow, spinning hat, amazing. Okay, so what do we want next? Well, what we probably want is one state for staying and one state for returning. We want a staying state because we want the ability to throw a hat and then make it wait there until we release the button or something else. And for our returning state, it might seem like that's kind of arbitrary, but remember, we're in a finite state machine, and every single point or every single action that your cap takes must fit within some state. Okay, let's get started on a staying state. Make a new state, call it stain, and I'm also going to assign the I'm going to assign the flying animation to it. Yeah, just for polish. I'm gonna add a new behavior for it, call that stain. Double click. And okay, so what we're going to be doing is if you're holding down your key, it will stay, and once you release, it'll come back to you. Or it'll release, or if you never even hold down the key, it'll return to you after some time. So the two things that we'll need is public key code, oh, probably not even public, private key code, private key code stay key. And we're also going to want a public float return delay. And we're going to be using onState enter and onState update. I'm gonna store the reference to our hat component this time. Good coding hygiene, you know, the thing that I didn't do earlier. Oh, whoops, sorry. Hat, just hat. And we are going to say stay key is equal to controller dot key. Dang it. Okay. All right. So now we want a kind of complex. Oh, sorry. I got that wrong. We're not going to be using state update. We can get rid of that. So we're actually going to be making a an enumerator. For those who have not used this before, this is kind of, oh, I'm not even typing anything. What? An enumerator is kind of like a timer. You're able to use something called yield return, and pretty much what that does is it delays the termination of this function. It's a little hard to explain. You'll be able to see it better when I actually add it in. This will be taking in a float delay and an animator. Okay, so we are going to make a float timer equals delay. We're going to make a while loop, and we're going to have a yield return new wait for seconds, and let's just say, like, you know, small number 0.01. And let's just say larger, so I can explain this without errors. So when you have a while loop like this and a yield return inside of it, inside of an enumerator, the idea is that this enumerator will continuously play this while for as long as this is true. And since we have this yield return new wave for seconds, whatever you put in this while loop will happen every 0.01 seconds. Obviously, we don't want it to always be true because we don't want it to happen forever. But I just wanted to explain this kind of pattern to you guys. Alright, so we have a timer. Let's say while our timer is greater than 0, right? And then inside here we would do timer minus equals 0.01. So now you can kind of see whatever delay that we call this with will be how long this while loop goes. Would yield return null work? I'm actually not sure. I don't really remember what yield return null does. I think it would just not wait for seconds, so rather than this happening every 0.01 seconds, it would run every frame. Yeah, I guess that would work too. Yeah, that would work too. You know what? Let's actually try it. Yield return null. Yeah, but I'm still going to keep this because I want it to be time dependent. Okay, so while timer is greater than 0 and we decrement our timer, so okay, and one last thing that we're going to add at the end of this is animator.play and returning. Okay, so now we can see that for however long this while loop lasts, when this while loop ends, we're going to change states. So that means we also want an or input.getKey and we're using the state key. So as long as the timer is greater than 0, or you're holding down the key, we will not go to the next state. Hopefully that makes sense. If you have any questions, let me know. And finally, we want to actually call that enumerator. But oh no, start coroutine, the thing that the function that you often use in mono behavior like this, and you put a coroutine in here, doesn't work. And you're like, why not? Well, it doesn't exist, idiot. Nah, sorry. Getting a little too aggressive. What you can actually do, since start coroutine is a mono behavior function, you can actually use your reference to the animator, which is a mono behavior, and call start coroutine from there. Okay. I think, yeah. Yeah, so you call it from that component. Kind of like utilizing that mono behavior from there. Yeah, so animator kind of becomes your mono behavior when you're working within these state machine behaviors. Okay, so let's put in return delay and the animator. Oh, sorry, not the animator. We're going to be using the controller. Because the controller inherits from mono behavior. My bad. Yeah, that's what I meant. Yeah, so any function that you want to call from mono behavior, you can usually get it from that script that you attach. That's another reason to use that kind of pattern where you have a mono behavior attached to it while you also have these state machine behaviors. Okay, let's see if that worked. And we're also going to have to make a return state before we test this out. We'll call it returning. And we're not going to give it a motion. And that will help us visualize when it goes from staying to returning, because once it goes to returning, the hat will stop spinning. Okay. And I'm going to throw it and hold my mouse down. Cool, cool. It's spinning. And now if I let go of my mouse, well, dang it. Whoops. I think it's staying and throwing. Did I not? Oh, right, okay. Alright, good catch. I forgot to do this. So for throwing, I want it to... Okay, so there's no player action associated with going from throwing to staying, right? Because it finishes its throw, and then it just starts staying. Since the player doesn't have any control over that, we're going to use a transition. So right-click, make transition, and then click on the state you want it to transition to. What we're going to be doing is that we are not going to have any exit time. We're going to get rid of exit time. We're not going to get rid of exit time, we're just going to set it to 0. And we're going to make transition duration the same as our throw time. So throw time is 0.5, and we'll make it the same. So transition duration 0.5. Okay, so now it should do it, hopefully. I'm just gonna like click and then not hold it down. Cool. Error. Wait, why do we need a transition? So this transition will just naturally change the animator state from throwing to staying. It's almost like what we've been doing, like the animator.play, except it does it within the animator, which is just easier in some cases. Because recall, in our throwing script, we don't have any state changes. We need to do it somewhere. And I think the cleanest way to do it is with this animated transitions. Okay, so what was that error? Oh, I forgot to set the throw key here. So if you click on Mario Hat, I didn't, wait, Oh. Okay. Right. I forgot. I'm using the new version of Hat controller, so we're gonna have to update what script we try to access here, which is Hat controller now. Sorry for the kind of weird naming convention. It makes it a little bit confusing sometimes, but this was just so that I could have like a more completed version halfway through. And with scripts, that's kind of annoying to do. Okay, so make sure that it doesn't say hat anymore. Make sure that all your hat things now say hat controller. Alright, so I should be able to test this now. Up to returning. Okay, so point, throw, and I'm holding down my mouse. It's not going to returning yet. And I release, and it stops. So that means it's in returning. And this is perfect. This is exactly what we want. Alright. Does anybody need to see anything at this point?
Can you explain again why we have to change from hat to hat controller? Because I changed it and now it's not stopping the spin.
Okay.
And before it didn't give me the error. So.
Oh, it didn't give you the error before?
Yeah, I don't know if I did anything different, but.
Before you changed it, was it giving you an error? Wait, no, sorry. Was it stopping correctly?
Yeah, it was.
Okay. Something that might have happened was that you were making, you were using the wrong Animator controller. Are you sure you're editing this one? You like double clicked it.
Oh, I see. I'm using the hat one that we made in the first folder.
Yeah, so make sure that you're altering this new one.
Okay.
All right. Do you need to see anything that I did here?
No, I think I'm good. Thank you.
Okay. Yeah. So just the transition with the same value here. I'm also gonna make return delay 1 second. Gonna do one more test. So this is with no mouse hold. I throw it. Oh. Okay, that took kind of a long time, but yeah. And then it stops by itself. Yeah, maybe 1 second's a little too much. Yeah. Okay. All right, now we want return to actually do something. So let's implement that. Make a behavior for it first. Returning. No. Get out of here. New script returning. Okay. And we have this new returning behavior. We're gonna import DG Tweening again. And we are going to be using enter and update. Okay. So if we're returning, we want a reference to the head. So let's add that in. Private transform head. And we also want a minimum distance. So this minimum distance is because we want to be able to check if we should go back to that following state, right? Because we want the hat to get near Mario, but we also don't expect it to be able to like perfectly position itself on this transform. So we're gonna give it some leeway, pretty much. All right. So head equals animator dot get to component hat controller. Make sure it's hat controller this time. And hat pause. There we go. All right. And inside of state update, we're gonna do animator dot transform dot do move. Head dot position, and we're just going to do a small value, 0.1f. Okay, so this is going to move the hat to the head position within this amount of time. And finally, we're going to check, if, vector3.distance, we're going to check if our hat is within min distance of the head. So head dot position, no, head dot position is less than min dist, brackets, and if it is, then we go back to following. And I'm gonna wait a bit in case anybody needs to see anything. Yeah, so something you might also be wondering is like, do I always need to know the names of my states? No, you can actually, I think you can define them. Like you can use an attribute and make it so that states are like called by some sort of string that you specifically set, and that's useful. But you know, we only have 4 states. We're not going to bother.
I have a question about the do move.
About what?
The do
Oh.
move we use.
Okay.
In like the throwing, we use do move, or do local move, but now we're using like a non-local version. What's the difference exactly?
Okay, so within Unity, if you parent something to something else, its position is now technically a relative position, and that means whatever values it has there, it's going to use its parent as the origin.
Oh.
Yeah. So when you apply a do local move, it will be changing that value in local space. So like it changes the relative value. But if you do a normal do move, it changes its actual position, which doesn't necessarily correspond to its local position. Does that make sense?
Oh, okay. Makes sense.
Yeah. There's no real reason why we do it differently for these two, because it doesn't have a parent. But I'm glad you asked that. It is an important part of using DG Tweening.
Thank you.
Yeah, no problem. Okay, I'm going to assume that people have this code now. And let's test it out. Oh wait, we also need to set min distance. Instead of here. Please. Come on. Okay. And I think I put that at 1. Let's test it. Alright. Throw. And I'm holding my mouse down, keeping it there. And now I'm going to release my hat. Oh, it goes back to me. Whoop. Oh man, it really does stay for way too long. I need to change that. Return delay is like 0.1 or something. But yeah, now that we've kind of like closed that loop of our states, we can see that, oh, we can see that it's, it actually looks pretty okay, pretty decent. And this was done with 4 states, very small scripts, and just like kind of an understanding of a state machine. Yeah, so you can kind of see that like if we're moving away from it, it like try to like follows you. We can simply fix that by increasing our min distance just a little bit so that it'll snap even if we're moving away from it. Yeah, the snap is very satisfying, and it's because it's just like we do a lot of just like smart tweening stuff that that makes switching between these states very easy and fast. So again, like I've been saying, using the state machine has been a lot easier than if I were to just do this all within, like, you know, a hat script, right? Imagine if I use hat controller like an actual script and just did this inside of that. It'd be kind of a nightmare. But you can tell, like, we got a fairly complex behavior just from the state machine, which is pretty nice, right? It also looks pretty nice because our animator is easily allows us to also incorporate some visuals to it. Yeah, but obviously we're still missing a couple of features. It can go through. Wait. Oh, dang it! I forgot to take out. I forgot to take out some code. Okay, well, the features that we are missing is that you still can't bounce on it. And the feature that I forgot to take out was that it's supposed to go through walls. I mean, it sometimes does, but like, it's supposed to do it more. So let me show you how you would do that in this kind of architecture. Okay, so let's get rid of that. We're not using it anymore. In the hat controller for this one, we have what we had before, but we also have this piece of code. And you can see that I use a onTriggerEnter inside of this mono behavior because I can't do it in the state machine. And that introduces a couple of problems. For now, we're just going to say it's good enough. If we have a trigger enter, the hat is a trigger collider. So if the hat collides with if the hat collides with anything that is not the player, and it's in the throwing state, it's going to change its state to staying, and it's going to kill any motion or it's going to kill any tweens that have been applied to it. And this is relevant because your throwing animation, your throwing state is when it's going to be moving forward, and this is just going to make it stop and kind of like start the next state early. Sorry, I was just thinking because like this throw time seems kind of weird. Like it's. Let me actually let me check something. Yeah, no, it's the exact same thing. That's weird. Okay, never mind. Okay, so that is how we made it stop on geometry. Now let's implement that cap bounce, and that's the last thing we'll be doing. So make sure you pay attention. Inside of this onTriggerEnter, we want to check if the player collides with the hat. So let's do that first. is. Okay, so most of the time you would want to check if the hat has a tag or something that says hat. I forgot to do that, so we're not going to worry about that. It also doesn't matter because the hat is the only trigger that the player is going to be interacting with, but usually you would want to check. Okay. So the first thing that we'll try to do is we will store a reference to the animator. I keep on spelling it wrong. Anim. And we're gonna get that component off of other. Again, you would want to check if it's the hat because not all objects would have an animator always. Alright, so then we do this crazy statement where it's get current animator state info 0 and dot is name, right? Is it not? Oh, not clip, state info. And then is name staying. And that's going to check if your current state is staying. It's a really huge function and it's kind of annoying to use. And it's because their state info is stored in its own data struct. So you can't just access the name directly. Also, this parameter, 0, that actually refers to the animation layer. Something you might not know is that the animator can be made into multiple layers, where like one of these states holds other states. They're called substates, and they have this like kind of hexagonal shape. If you double click them, it brings you to a new animator level, and like you can go up a base level, and that's like a lot. With state machines, you could probably like do a lot more stuff with that if you like go down a level, inception your state machine. We're not going to worry about that. Just know that your base layer is going to be that index 0, and that's going to let us check our states. Okay, so if your player collides with your hat, you probably want your hat to just return to your player. That's how it works in Mario Odyssey. It doesn't like keep on staying or anything. And this is just the line of code that will make you bounce. That's just some character controller stuff. You're probably just gonna have to trust me on that, that this works. Yeah. So I'm gonna stay on that level. But at this point, we should have a cap that can be thrown, can be held in one position, will return to you, something that you can jump on, and something that will not go through geometry most of the time. All right, let's test it out. Come on, okay. Throw the hat, make it stay, make it come back, cool. So that part still works. I think it won't go, it kind of goes through geometry. Oh, maybe not. Yeah, okay. It doesn't go through geometry. And bounce. boing. Cool. So hopefully everybody's hat lets them bounce now. If you have any issues, this is pretty much all the content that we were gonna go over today. So if you're having issues, please feel free to ask me questions now. But if you don't have any questions, thank you for coming. I really hope you learned some new coding practices and maybe like an archetype that you might want to really expand on and build a game around. All right. And again, slides, as always, slides will be posted after the workshop. I never know how to end these workshops. But yeah, thank you everybody for coming. All right, opening the floor to questions now and debugging. Does anybody have a hat that does not hat in this way?
I don't have any questions, but I think this workshop was very cool.
Thank you.
Me too, this is pretty cool. I liked it a lot.
I agree.
That's good, that's good.
Can I ask a question that's a little bit unrelated?
Go ahead.
For the library that you use, how do you get a library into Unity?
Yeah, so I say library, but it's actually just a Unity store asset.
Okay.
Yeah, and you can download it into your project, like the same way that you would do anything else, pretty much.
Cool.
Mm-hmm.
Can you use it for 2D games too? Is that what you used for Cargo?
You can definitely use this for 2D games. I did not use it for Cargo. I did way worse coding practices for that game. But for 2D, it actually works just as well. You'd obviously be using some different logic in your behavior scripts, like your state behaviors. You probably wouldn't be doing something like forward or something. I mean, it'd be mostly the same, but like, 2D specific stuff. You would definitely still be able to use it though.
Nice. Thank you.
Yep. I also, man, I wish I had enough time to do a dive, but like, that just seems hard. Hard to make it satisfying, I also really like how you can like do a short hop and then like position the hat a little higher. Obviously not on the quality of Mario, but we're ripping off his main mechanic. That's good enough for me. What? No. Okay, so I'm just gonna guess that there's no more questions. I am down to just hang out in this room call, but I will stop streaming.